The declassified aerial photograph tells a story of sheer desperation and defiance. Taken by a lone Yuzov reconnaissance plane in late 1944, it shows a slender, man-made thread spanning a deep, green slit in the earth, the Tanai Hka River Gorge in northern Burma. Snaking across it is a serpentine column of men, trucks, and mules. The official caption is sterile: Bridge, Bailey type, near Tingkok Sakan. The men on the ground had another name, the Suicide Bridge. The situation was catastrophic. 10,000 Allied soldiers, the entire Chinese 38th Division, were trapped. Cut off from supply and with the veteran Japanese 18th Division closing its vice, their annihilation was a matter of days. Their sole hope was this single crossing. U.S. Army Services of Supply terrain analysis maps stamped the location impassable to major forces. Standard engineering tables mandated a minimum of 3 weeks to erect a Bailey Bridge of this span under ideal conditions. The commanding general issued an impossible order. You have 72 hours. This is the documented story of how American engineers, operating in the world's most hostile jungle, with monsoonal rains turning ground into soup and Japanese snipers in the overlooking hills, defied every textbook and staff assessment. Using modular steel components, brute manpower, and ingenuity born of necessity, they built not just a bridge, but the pathway for a decisive counteroffensive. It was a miracle of logistics under fire. But how did this suicide bridge, a structure that should not have been built in time to matter, come to exist against all odds? To understand the scale of this gamble, official intelligence reports first reveal the enemy that had the Allies trapped. The force holding the trap shut was the Imperial Japanese Army's 18th Division, the famed Chrysanthemum Division. These were veterans of the Malayan Campaign and the conquest of Singapore, hardened by years of brutal jungle warfare in northern Burma. Their doctrine was to turn the terrain itself into a fortress. They expertly fortified ridgelines and riverbanks, creating interlocking fields of fire designed to slaughter any force attempting a deliberate, slow-motion crossing. Their commander, Lieutenant General Shinichi Tanaka, assessed the Allied predicament with cold confidence. In later interrogations, he revealed his belief that the mountains and raging monsoon rivers formed an impenetrable natural fortress. His strategy was not to meet the Allies head-on in open battle, but to let geography and logistics win for him. He had seen it work before. Throughout 1943 and early 1944, Allied advances, like those in the Yukon Valley, had repeatedly ground to a halt, strangled by impossible supply lines over the mountains from India. The Japanese war diaries, later captured, show a clear calculation. The monsoons and the bottomless gorges of the Tanai Hka region would do more to stop General Stilwell's Chinese-American forces than Japanese bullets. This confidence was amplified by signals intelligence. While the Allies' ultra-codebreakers were reading Japanese messages, the Japanese High Command's own assessments, intercepted and translated, repeatedly cited enemy logistical paralysis as a key factor in their defense. They had fortified the far side of critical rivers like the Tanai Hka, anticipating a slow, predictable Allied engineering effort. Their plan was to let the bridge building begin, then destroy the vulnerable concentration of men and equipment with concentrated artillery and mortar fire. In their view, the gorge wasn't an obstacle. It was a killing zone. Facing this entrenched, confident enemy were Allied forces plagued by what official supply reports bluntly called crippling logistical paralysis. The Allied advance in northern Burma was a battle fought less against the Japanese than against the earth itself. This was the theater of endless disadvantages. Every bullet, bandage, and beam for General Joseph Stilwell's Northern Combat Area Command traveled a 12,000-mile oceanic route from America to India, then a 500-mile airlift over the hump of the Himalayas, before finally being trucked down the precarious, unfinished Lido Road. This tenuous thread was their lifeline. The Lido Road project was itself a nightmare in engineering and human endurance. U.S. Army Surgeon General reports from 1944 reveal a staggering truth. Disease, not enemy action, was the primary casualty producer. Malaria, scrub typhus, and dysentery incapacitated men at a rate 5 times higher than combat wounds. The jungle was a hostile, draining entity. British liaison officers, in confidential reports, labeled the entire offensive a logistician's folly, doubting any major force could be sustained so far from a real base. When Stilwell's Chinese-American force, including the famed Merrill's Marauders, finally pushed into Burma, progress was agonizingly slow, measured in yards per day. Each river crossing became a days-long ordeal of building footbridges or makeshift ferries under constant sniper and mortar fire. The Tanai Hka Gorge was the deepest and most formidable obstacle yet. Contemporary War Department newsreel footage shows engineers, waist-deep in leech-infested water, battling monsoonal currents with hand-operated pile drivers. The official intelligence assessment was bleak. A force the size of the 10,000-man 38th Division could not be supplied across this chasm in time to prevent its destruction. But hidden in the mountainside depots of the Lido Road was a secret weapon. Not a weapon of destruction, but of creation. The secret weapon was not a tank or a bomb, but a bridge. Specifically, the Bailey Bridge, a revolutionary system of modular, prefabricated steel panels, transoms, and bracing that could be configured for almost any gap. Conceived by British engineer Sir Donald Bailey in 1941, it was essentially a portable, military-grade erector set. Its genius was in its simplicity and flexibility. It required no heavy cranes. Components were man-portable and could be assembled with winches, jacks, and sheer muscle. Crucially, it could be constructed from one side of a gap and launched across, a vital feature when the far bank was held by a hostile enemy. While British-designed, American industrial might scaled it for global war. U.S. factories, under War Production Board directives, churned out thousands of tons of standardized panels and components. Hundreds of these sets were shipped to the China-Burma-India theater, stockpiled along the Lido Road for the inevitable moment when a river would stop the advance. But the hardware was only half the story. The true innovation was doctrinal. U.S. Army Engineer Combat Battalions, like the men of the 209th, trained relentlessly on Bailey Bridge assembly under simulated combat conditions. Field Manual 5-36, Route Reconnaissance and Classification, devoted entire sections to rapid site selection and Bailey emplacement. The bridge represented a fundamental shift, turning the complex, time-consuming art of military engineering into a reproducible, industrialized process. The plan for the Tanai Hka wasn't a desperate improvisation. It was the premeditated application of a rehearsed, factory-born solution to a primal, medieval-scale problem. The engineers, in theory, knew they could build the 180-foot double-single Bailey span the situation demanded. Their technical manuals contained the calculations. Their depots held the components. The unanswerable question in the manual was whether they could execute this complex, exposed ballet of steel while monsoon rains turned the ground to quicksand, and veteran Japanese infantry on the high ground rained down mortar shells and sniper fire. The bridge was a known quantity. The clock and the enemy were the variables. As the trapped 38th Division dug in for a last stand, the 209th Engineer Combat Battalion received orders that turned their training into a deadly, real-world countdown. The clock started with a convoy's grinding departure. D-72 hours. According to the 209th Engineer Combat Battalion's unit diary, a column of 42 overloaded GMC 6x6 trucks, carrying 400 tons of pre-assembled Bailey Bridge panels, transoms, and rollers, began the treacherous crawl from the Lido Road depot. Their route was a single file, muddy trace barely wider than the trucks themselves, winding through jungle where Japanese patrols still roamed. After-action reports laconically note intermittent small arms fire, harassing the column, a constant reminder the enemy was watching. Japanese signal traffic, intercepted by Ultra, detected this movement. A dispatch from the 18th Division's headquarters noted increased motor transport activity on the Lido trace. But their assessment, as decrypts revealed, was fatally complacent. They logged it as resupply for stalled frontline units, not the precursor to an engineering offensive. They believed the gorge remained their unbreachable moat. At the gorge, chaos reigned. Under covering fire from Chinese outposts, engineer survey teams scrambled down the near slope to take preliminary measurements. The numbers were daunting. They needed a clear span of over 200 feet across a chasm plunging 180 feet to a raging river. Aerial reconnaissance photos, rushed to the site, confirmed a small blessing. The Japanese held only the high ground on the far side of the gorge. The near bank, while exposed to fire, was physically clear of enemy troops. It was the only place from which a Bailey bridge could be launched. The first truck, caked in mud, arrived at the lip of the abyss at H-hour-71. The components were unloaded by hand in the fading light, a mountain of steel growing in the jungle clearing. At dawn on the first day, with a cold, clinging fog masking the gorge, the first 10-foot-long, 600-pound steel panel was manhandled into position on the makeshift abutment. The construction of the suicide bridge had begun. Day 1, foundation and launch. The operation began with the shriek of rivet guns and shouted commands, building the angled launching nose that would spearhead the bridge across the void. Within hours, the first skeletal ribbon of steel began crawling over the chasm. The noise immediately drew Japanese attention. The crack of sniper fire began whipping across the gorge from concealed positions on the far rim. Work became a deadly ballet of ducking and building. That first day, Technician 4th Grade James Cobb was wounded by mortar shrapnel but refused evacuation, remaining exposed to guide a critical panel into alignment, an act documented for the Medal of Honor. Day 2, the push and the counter. A grim rhythm set in: panel, transom, sway brace, decking. As the bridge extended, it became a clearer target. Japanese mortars, pre-registered on the crossing site, began walking rounds along the near bank and the structure itself. The 209th's casualty roster began to fill with names. This was no longer just an engineering job, it was an integrated battle. American and Chinese combat units responded with a torrent of suppressing fire. Mortar teams lobbed smoke and high explosive onto the Japanese ridges. Machine guns chattered, forcing enemy snipers to keep their heads down. It was a combined arms ballet where the engineers were the principal dancers under the spotlight. Day 3, the final connection and the test. Exhausted, caked in mud and sweat, the crews worked through the third day as the bridge inched toward the far cliff. Japanese fire intensified in a final, desperate attempt to stop the connection. Just before dusk on November 18th, with shadows stretching across the gorge, the final panel was maneuvered into place. The master sergeant raised a sledgehammer and drove the last key pin home. The structure was complete, but the true test remained. Following doctrine, they didn't send a jeep. They ordered forward a fully loaded, 16-ton M3 Stuart light tank from the Chinese armored unit. Every engineer watched, breath held, as the tank growled onto the near approach, its tracks clattering on the steel deck. The bridge groaned audibly, settled under the immense weight, and held firm. An engineer officer later wrote, "The bridge groaned, settled, and held. A sound more beautiful than silence." By the numbers, from unit records, 72 hours of continuous work, 18 casualties from enemy fire, 412 tons of steel, one bridge. As night fell, the 1st Infantry Scouts crossed, securing a small bridgehead. The 38th Division's escape route and its new attack avenue was open. The effect on the Japanese defenders, as recorded in their own communications, was one of utter disbelief and tactical disaster. The Japanese reaction was a cascade of shock, panic, and collapse. Captured dispatches from the 18th Division's frontline units, translated by Addis, tell the story. An initial, panicked message from a battalion commander: "A large bridge has appeared as if by magic at the Tanai crossing. Enemy tanks are crossing." This was followed within hours by frantic orders from regimental headquarters to hold at all costs. And then, as the tactical reality became undeniable, a final, grim directive: withdraw to secondary line. Preserve the force. The impregnable river barrier, the cornerstone of their defense for months, had been transformed overnight into a high-speed Allied highway. Their fortified ridges were now outflanked. The terrain that had been their greatest ally was suddenly irrelevant. Post-war interviews with Japanese veterans, collected by their own War History Office, reveal the depth of the psychological blow. One lieutenant confessed, "We had prepared to destroy a slow, vulnerable pontoon bridge. We were not prepared for a steel highway to suddenly cross the sky. Our morale broke with the sound of the first tank crossing." The suicide bridge lived up to its name, but for the Japanese defensive scheme, not the American engineers. Their entire position, meticulously prepared over weeks, unraveled in a single morning. U.S. intelligence summaries from November 20th report the Japanese 18th Division was in full, disorganized retreat, abandoning heavy mortars, artillery pieces, and stockpiles of ammunition in their prepared bunkers. The force that had been confident of annihilating the trapped 38th Division was now fleeing to avoid encirclement. The bridge was more than a local victory. Its completion sent shockwaves up the chain of command, altering the entire strategic calculus of the Burma Campaign. The operational impact was immediate and explosive. With the gorge crossed, the revitalized Chinese 38th and 22nd Divisions, now reinforced with American artillery and the 1st Provisional Tank Group, poured across the bridge in a relentless offensive. This renewed momentum directly enabled the capture of the critical Myitkyina airfield weeks ahead of schedule, a victory General Stilwell celebrated in his personal diary, writing, "The Tanai Bridge changed everything. Myitkyina is now a question of when, not if." Logistically, the Suicide Bridge became the indispensable artery of the final push of the Lido Road. U.S. Army Signal Corps footage from December 1944 shows an unbroken stream of Studebaker trucks, carrying fuel, ammunition, and troops, rumbling across this and subsequent Bailey bridges. What had been a trickle of supplies over precarious ferries became a sustained flow, turning Stilwell's Road from a theoretical concept into a functioning military highway. Allied morale, both at the front and at home, skyrocketed. The CBI edition of Stars and Stripes ran a triumphant front-page headline, "Engineers beat Impassable Odidius. Road to China open." This stood in stark contrast to the skeptical reports from earlier in the year. Time magazine declared the breakthrough had cracked the stalemate in Burma. For the Japanese, the consequence was a catastrophic contraction. The loss of the Tanai HKA line forced a major, hurried withdrawal of their entire northern front. This retreat hastened the eventual link-up of the Lido Road with the Old Burma Road in early 1945, finally reopening the land route to China. A single engineering feat had turned a tactical crisis into a theater-wide strategic reversal. Beyond its immediate wartime impact, the legacy of this bridge and the thousand like it built across the world defined modern combat engineering. The Suicide Bridge at Tanai HKA represents a pivotal moment in the history of warfare, transcending its immediate tactical purpose. It stands as a supreme testament to the Bailey Bridge system, which military historians rank among the most impactful inventions of World War II, alongside radar and the Jeep. As Royal Engineers historians have argued, it was effectively the bridge that won the war in multiple theaters, by enabling the mobility that Allied combined arms warfare demanded. More profoundly, the operation perfected the modern doctrine of combat engineering, the rapid execution of complex construction under direct enemy fire to directly influence the close fight. This was not mere field engineering. It was a combat arm executing a high-stakes mission under fire. The synchronized actions of the 209th Engineers, building while infantry and artillery suppressed the enemy, created a blueprint. This doctrine was codified into U.S. Army cornerstone manuals and became the standard for engineer units in subsequent wars. In Korea, the 299th Engineer Battalion employed identical Bailey bridging tactics at the Chongchon River. In Vietnam, the ethos persisted in rapid airfield construction and riverine crossings. The legacy echoes in modern parallels, the rapid emplacement of pontoon bridges by mechanized bridge layers, or the construction of expeditionary airfields. It is ingrained in the U.S. Army's Sapper School ethos, where the engineer's mission is to reduce the enemy's obstacles and create obstacles for the enemy. The ability to dynamically reshape the battlefield's physical geometry is recognized as a weapon system of decisive power. The Suicide Bridge was not a fluke or a mere stroke of luck. It was the vindication of meticulous preparation, scaled industrial production, and adaptable, well-drilled doctrine. It proved that in modern war, logistics is not just about moving supplies, but about moving forces across impassable terrain. It demonstrated that a prepared engineering force, equipped with modular technology, could change the strategic map in 72 hours. So, what is the ultimate lesson from this span of steel in the Burmese jungle? The story of the Suicide Bridge delivers a definitive, documented lesson from World War II: sheer willpower, when multiplied by systematic innovation and backed by industrial might, can overcome even the most absolute geographical advantage. Japanese commanders trusted the immutable jungle. American engineers trusted the mutable, relentless power of human ingenuity applied through steel, sweat, and doctrine. By war's end, over 70,000 Bailey Bridge units had rolled off Allied production lines. They spanned the Rhine, the Volturno, and the Irrawaddy, becoming the ubiquitous arteries of the Allied advance. But perhaps none were as vital or built under such relentless duress as the one thrown across a forgotten Burmese gorge in 72 hours. The bridge that saved 10,000 men, shattered an enemy division's confidence, and cracked open the final leg of the road to China. This is just one of hundreds of untold engineering sagas from World War II, where the battle was not just against men, but against mountains, rivers, and physics itself. Subscribe and hit the notification bell, because in our next video, we're diving into a plan so bizarre it seems like science fiction. The iceberg ships of Project Habakkuk. The Allied scheme to build unsinkable aircraft carriers out of a secret material called pykrete, a mixture of wood pulp and ice. A plan so audacious, Winston Churchill himself championed it, and so strange it had to be seen to be believed. History documents. Never tell an American engineer something is impossible. They'll just build a bridge over it.